and welcome to building your own widget with the ArcGIS API. I am with my colleague Matt Driscoll, Widgeteer extraordinaire, and I am JC Franco. We both work in the JavaScript API, developing widgets and working in UX UI matters. So let's get this started. So the agenda for the day is we're going to start off by showing how to set up your dev environment if you want to develop widgets with the JavaScript API. And then we are going to go through a step approach on developing a game widget. And we're going to start off by showing how to build a simple class that is going to be the foundation for our game, and then show a simple widget that is going to show you the basics of just getting a widget to render. And then afterwards, we're going to combine the two so that we can show how we build widgets in the JavaScript API, where we have the business logic and view concerns separated. And then afterwards, we're just going to show you what you would end up with if you dedicate a little bit more time and add a little bit more polish to a widget that you have in mind. So with that, to start off setting up the dev environment, I'm talking specifically about getting started working with the JavaScript API and TypeScript, because the widgets are developed using TypeScript, and this is because we have a set of decorators and other helpers to kind of remove a lot of complexity and in terms of how the widgets are wired up. For example, we have some utilities to mark properties in such a way that whenever they change, the UI will refresh. So we're going to start off with TypeScript. And if you haven't heard of TypeScript, it's basically JavaScript that knows how classes are structured, the properties that belong to it, the signatures of the methods. For example, it allows you to define the shapes of different objects and classes. If you look at this little snippet here, I'm defining a person, which will contain a name of type string and an age type number. So if later on I define a person with a certain properties, if I try to assign the age property with a string, TypeScript's going to complain and let me know that you're doing something wrong. So this is pretty cool because up front, it's going to help you catch errors and minimize pain in trying to debug issues that may come up later on in development. Another neat feature is that it allows you to harness features that are still upcoming in the different JavaScript environments. For example, if you have a browser, if you're targeting a browser with ES5, you can use ES6 syntax, and by configuring TypeScript correctly, it'll transpile the ES6 code into ES5 compliant code. So some of the examples of stuff that you could do with TypeScript without really, even if the browser doesn't support it, if you configure it properly, you can use let and const. So this is pretty useful if you want to define variables that should not change at all. Yes. And you can also define fat arrow functions, which is just syntactic sugar to kind of have a more concise way of writing methods. Template strings are also pretty useful, since it allows you to define a string that is readable that will plug in variables from an object, for example. Destructuring is pretty nice too if you want to kind of assign multiple variables within one statement. And property shorthand also helps you keep your code concise by minimizing some code that you need to write. In this example, if I have a property on an object called person, and the value that is getting assigned to it is also named person, you can just do it this simple way. Another neat thing is that TypeScript is widely supported now, so bringing it into your browser of IDE of choice is much simpler now. So for our first demo, I will be just setting up JavaScript and the JavaScript API and TypeScript in a folder directory to start with our widget. So what I have here is let me bring up my steps. So I am in my project directory, right? So the first off, I need to initialize this project to be an NPM project, an NPM module. And I can do that quickly just by using npm init and then the yes flag. And what this will do is it'll initialize that project as an npm module and give you a default out of the box configuration. So now you have an npm module. And what this allows me to do is it allows me to bring TypeScript, other npm modules such as TypeScript or the JavaScript API typings. And typings, what it is essentially a set of files that would tell TypeScript how the JavaScript API classes and objects look like so that it knows the signatures and it'll help give us IntelliSense. So if I do this correctly, what it'll do is go ahead and fetch these modules and install it into your npm project, to your module. And if I check I didn't mention this, but when you initialize an npm project, it creates a package.json, which is the definition of the configuration for this npm project. And it also, I'll bump up the text. It'll set here the list of dependencies, either for development or just for it to execute. And what we just did is install the types and TypeScript for this project. So now what I can do, since I have TypeScript here, is also initialize TypeScript within my project. And what this does is it'll create a default tsconfig.json, and it's just the configuration file for TypeScript. And by default, it'll enable a few flags and also give me it'll comment out all the available options and a brief description, so guiding you at getting set up quickly. So for this demo, I already have a config that I'll be using, so I'll just copy it over. Cool. And this config you'll find if you go to our SDK page on how to get started with TypeScript. It's the same one. So this is the same base that we use to develop our widgets. Cool. So moving on, I've now installed the types for the JavaScript API and TypeScript. So what I can do now is run the TypeScript compiler in watch mode. And what this does is it'll run the compiler. It'll look for all the applicable TypeScript files and start compiling if it notices anything change. And when you use the watch flag, it'll watch for any changes to all the TypeScript files that are configured in your tsconfig. So as soon as anything changes, it'll recompile without you having to do anything. So now we have TypeScript running in our project. And what I have here is a small snippet of a very simple mapping application. It's just setting up a map, right? It's creating a map and creating a view, assigning a container to the view, the map to this map view, and center and zoom. So TypeScript is, the compiler is watching for changes and it detected, recompiled. So if this was originally blank, and once I refresh, it'll pick up the files that we just compiled, and we have a very simple application. And that is all you need to do to get started. So just to recap, we went over how you would set up your project to bring in TypeScript and the JavaScript API typings, and we built a very, very small mapping application. So, okay, that's the first step at getting to develop our widget. So the next step we'll be focusing on is creating a class. And in the API, from the API's point of view, this means creating a class that extends accessor. And accessor is the foundation for all the classes in the API. And what it gives us is a consistent API or developer experience. So this means when you are extending and creating a class that extends accessor, you get all the benefits from all the other API classes. So if you've been to the SDK, you'll see that a pattern that we use a lot is watching for properties. So if you have an instance, for example, a person instance here, and you want to watch whenever the age property changes, you can do that with the watch method. So you call watch, pass the method name and a handler, and whenever this property changes, it's going to invoke that handler. Another thing that I should have mentioned before is that it also gives you this consistent pattern of initializing your objects. So when you create a new object and it extends accessor, you can pass all the values for the properties of this class inside of an object. So instead of having different signatures to create different classes, it's consistent across the API. So for our first demo, we're going to start off by creating our Guess Where game class. And this is the interface that we'll be developing. It is going to extend accessor. It is going to require a view, because the way this game will work is when you initialize, it's going to go to a location, and you will be able to define choices. These choices will be two locations, two or more locations. In this case, it's going to be two locations, and it's going to keep track of your points or score, and it's going to have methods to start the game, to submit a choice on what location you're currently at in the view. You can also stop the game. And the shape of a choice is just going to be a name for the choice and a feature, which is a graphic. And the idea is that as we play the game, we have two choices, and it's going to zoom to one of these choices, and then you'll have to provide an answer trying to guess where the location is, right? Hence the name. So let's start off. Okay. So I have my placeholder Guess Where game class. In my project, I have my main class. And what I'll do is I'll start off by adding some boilerplate to get you started with a class. So what this is doing, it's just creating a class that's extending accessor. And that's all you need to create a class, in essence. But there's not a lot of use if you don't define properties, right? So let's go ahead and define some of the properties that map to that interface that we just looked at. So I brought in a few properties. So I brought in the choices, the points, and the view properties. TypeScript is already complaining because I'm typing these properties as some interfaces that I haven't defined yet. I'll do that in a little bit later. But I just wanted to call out that, for example, here I'm defining choices, and it'll be of type choices. Points will be a number, and it'll start at 0. And view will be either map view or scene view, which we do because we want to support the game to work in 2D and 3D. Each one of these properties is using the property decorator, which allows you to define an accessor property in your class. And for some of these, we mark them as read-only. We don't want the user to change the value. We want to set that internally. So let's bring in those other dependencies that TypeScript is complaining about. So I went ahead and brought in everything wholesale, so we don't have to go back and forth. But I'm just bringing all of the different classes or interfaces that I'll be referencing in my class. We'll also define that interface, the interface for the constructor. So remember we talked about how when you extend accessor, you can instantiate a class by passing an object. Well, TypeScript just knows that you can pass an object, but it doesn't know exactly what properties this class will take. So that's why we defined this guessware properties interface. And all it needs is for you to provide a view, which is going to be either a map view or a scene view. So we've defined all of our properties that we defined in our interface. Now we're going to move on to the methods. So to start off, we have the start method, and it's going to call an internal set next choices method to get started with. It'll pre-populate the next set of choices for the next round, and it's going to reset the points. I have next my, I just realized this is too small. Let me bump it up. Next we have the choose method, and it's just going to determine whether the choice that you provided is the correct one. If so, it's going to give you a point, and then it's going to reset the next set of choices, and it's going to return whether your answer was correct or not. And then the end, the end method is just going to remove the graphics from the game, from the view. So TypeScript is complaining about some missing variables and methods, so let's go ahead and add those. And to get started, I will be hard coding some choices for the game. So the game itself will only give you an option. Will have you guess whether it's Palm Springs, Redlands, or San Diego. We'll improve this later on, but for now, this will get us started. And then I also have an internal index to know which one of the current choices is the correct one. And then we have these other internal methods to set the next choices for the next round. It's just randomizing between the two choices and assigning the index. And once that's done, it's going to go to the next set of choices, and it's going to get the correct one and move the view to the geometry of that choice. So with that, we've created our game class, and we can update our main application. This is extending the previous one that we created in the previous step, where we are just creating a new map and a new map view. Now what we're doing in addition is importing the guessware class. We are creating a new instance and passing that view. And in the console, whenever the choices are updated, I'm going to be communicating whether it's choice A or B. And if we guessed correctly, we're going to notify that we got points, otherwise it's not going to say anything. So with that said, let's give it a try. So I have my game class here instantiated, so all I have to do is start. And if you notice, it took me to one of those internal locations, and it's either Palm Springs or San Diego. This looks like Palm Springs because there's a lot of things that say Palm Springs. So I'm just going to call the choose method with one of these answers. So since Palm Springs is the first choice, I'm going to assign it the first choice in the available choices. And then we got points. And then it went to the next set of randomized choices. And we can continue guessing, and it'll give us points accordingly. So for example, I was wrong. So this is the core of our game logic. So the end product will end up with a game with the same kind of workflow. But for this, for now, this is going to mark the end of our custom class. And to recap, we implemented the guessware, which is the core of the game. We did that by extending accessor. We defined a few properties. We typed the constructor so that TypeScript will detect if we don't pass the necessary properties for this class to work. And we also defined public and private methods. And with that, I'll hand it off to Matt to start writing a widget.
Thanks, Franco. So Franco showed us how to create a class based off of accessor. I'm going to be showing you guys how to create a very simple widget. But first, let's talk a little bit about widgets. What are they? Basically, they're single-purpose pieces of functionality, and they're encapsulated, so they're like a contained user interface part. And they're also unified and integrated and cohesive. And we do this to make them reusable. So I can create a widget and use it multiple times throughout an application or in completely different applications. And then if I want to update it, I only have to change it in one spot and it'll get updated everywhere. So reusable and interchangeable. And we create a widget in our API by extending the Esri Widgets widget class. This is the base class for our widgets. This class also extends accessor, so you get the common functionality that Franco was talking about earlier. So this class, like I said, it's a base widget class. All of our widgets extend it. It extends accessor. It allows you to set properties on a widget and also watch properties for changes. And it provides a consistent lifecycle for our widgets. Here's the lifecycle that our widgets get. We get a constructor where we can set up things when the widget's initialized. And then if we want to do some more stuff to that after the widget has been initialized, there's a post-initialize method you can hook into and set stuff. The main workhorse of the widget is the render method. And this method is where we define user interface and return JSX. And this method we want to call, or want to have get called every time we need to re-render the user interface. And lastly, we have a destroy method, which is where all the cleanup of your widget would happen. So for example, if you have some handlers that you need to remove, so there's not some memory leaks when your widget is destroyed, you would do that in the destroy method. So render, this is the main one. This is where you define your DOM structure and user interface. And it will react to any state changes. So if you have properties that you want to be renderable and then re-render the widget based on changes, you could do that. And this uses JSX, so React-like formatting, and virtual DOM. So we're going to create a really, really simple widget. And this widget will basically just be like a toggle button. It's going to have a property called enabled. And when we change that, we're going to have some user interface that changes the enabled from true to false. And it'll re-render and have a different class on the widget. This is kind of what it's going to look like. So right now, we just have a basic map. I'm going to go into my file structure. You can see my HTML file right now. It's just requiring a main JavaScript file. So I have a Dojo package set up to look for where that file is. And it is this file right here. So I'm just importing a map and a map view. And then I'm creating the map with the streets vector-based map and a map view right there. The first thing I want to do is open my simple widget. And this is the file I had defined there. It's a TypeScript TSX file. And I'm just going to create a basic structure for that widget. So you'll see here, my class is going to be called simple widget, and it's extending the widget class. It's going to have a property. It's going to use declared. It's going to have a renderable property and use TSX. And here's my constructor. Very simple right now. I have a section for public methods, where's my render is going to go. Private methods if I have those, and properties. So the first thing I want to do is make sure that I'm seeing something. So I'm going to update the render method. And this is going to return some JSX that is just going to display hello world in a stylized fashion. So if I TypeScript compile that, and then reload the page. Oh, there's one step I need to do. Before I even do that, I have to go into my main file and import my widget and start using it and add it to the View user interface. So here I have my map view. I'm going to import my widget that I just defined right there, and I'm going to initialize it and add it to the view. So now let's compile. And it should be positioned in the top right of my view there. Okay, so I'm seeing Hello World. It looks like a button, but doesn't do anything when I click it. So that's what we want to add next. And what we want to do is add a property to our widget. So I'm going to go into the section here where I have properties, and I'm going to add a property that is renderable. So whenever this changes, it's going to re-render the user interface. And by default, it's not going to be, it's going to be set to false. So enabled will be false. Then what I want to do is update my render method to actually use that property. So now I'm getting the enabled property from this class, and then I'm creating a class object where if it's enabled, I'm going to add this class for enabled. And I'm going to set the text of the button to either be enabled or disabled, depending on the state of this property here. And I'm going to return a button that has a click handler that toggles the enabled property. So let's do that. First, I'm going to define what these classes are. You'll see how that TypeScript is giving me a warning about that. I'm going to create a simple object where I have a base class called simple widget and an enabled class that it's a modifier class that will be added onto the button. And then let's add that private method toggle, which is being called right here when you click the button. I'm going to put that into my private methods. And then I should be able to compile this. Okay, go back into the file, reload. You'll see the state by default is disabled because it's false, but when I click it, it goes to enabled. So this is probably the simplest widget you can create because it's just one property switching classes. But it's a good starting point for creating a widget. So let's recap that real quick. I extended the base widget class. I implemented render. I added a property that's renderable, so when the state is changed, it will re-render the render method. I added an on-click event on one of the JSX nodes. And then I added a CSS object. And we're also using a methodology for naming our CSS called BEM. I won't really go into it, but it's a nice methodology to kind of standardize naming of classes. And then I toggled that property and caused it to re-render. So that's cool, but I mean, it's a really simple widget. Let's improve on it by separating concerns into a view and a view model. And also, we can do UI replacement because of that and integrate into different frameworks if we wanted to use view models. So what you just saw was a view. That's a simple widget example. It extended the widget class. Ideally, we want to rely on a view model. So we would separate logic and presentation. And in the view, you would focus on user interface and not some of the logic stuff. Whereas view models, this is the class that Franco created. This is where you would do most of the heavy lifting, data processing, asynchronous tasks, stuff like that. And this is where we'll extend the accessor class and provide APIs to the view, so the view just interacts with the view model, and the view model does the data crunching stuff and then tells the view what to render. So view models will focus on business logic. So here is an example view and view model in action. So the view would render the state of the view model. So it would look at properties and render them accordingly. Then a user might interact with the view via clicking on something or calling a method or changing a property. And that would cause a change on the view model. And then the view would see that change and update accordingly. So it would render again according to whatever the change is on the view model. So that's kind of how it would work together. So what we're going to create is this guessware game that Franco kind of talked about. I'm going to demo it really quick. So basically, you'll have a map view here, and the bottom part is the actual widget. So you'll get like a guessware intro page, and you can click start, and then you'll have to guess where these are. So I'm going to say that's Honduras. I'm going to say this is Sweden, and I'll get points depending on what they are. So if I guess wrong, I'm not going to get a point. So that's pretty much what we're going to create. So let's do that. So this may look familiar because this is what Franco created in the simple accessor class. What we're going to do is take that class and use it as our view model. And we're going to add a state to it. So this state will kind of tell the widget what to do depending on where the game is, basically. Whether it should show a splash page, or whether you're actually playing the game, or whether the game's over. So otherwise, it's the same interface that we created earlier with the accessor class. We're just going to take it and add a state to it and use it as our view model to render our widget. And then our view interface is going to look like this. We're going to create a guessware widget. So it's going to extend the widget class. And then it's going to take in a view so it knows what to show and where to show it. And it's also going to use the guessware view model that we're going to create. And this is the class that Franco created. So let's do that. We're going to use the guessware class as the guessware view model. We're going to add a state property. We're going to create a widget view. We're going to alias some view model properties. We're going to create some classes. And then we're going to render a menu, a heads-up display, and a round for the game. So here's what we're starting out with. We're going to start out with this widget that just renders hello world. And let me close this stuff and open up the next section demo. So this will be the updated view. And I'll just get my steps there and open up the view model. So this is the class that Franco created. It's the guessware extending accessor with all the same choices and properties and stuff like that. What we're going to do is just rename it. So we want it to be our view model. So let's rename it to guessware view model. And then export guessware view model. So all we did was basically rename the class from the guessware to guessware view model. And then we're going to add our state property. So I'm going to go down to the properties here of the widget and put a state in here. So this will be a read-only property, so users don't set this. It just gets computed. And we'll have to define what state is by adding a TypeScript type. And basically, if the widget is in its active state, it's going to be a splash screen. If it's not an active state, it's going to show the splash screen. If it is in an active state, it's going to show playing as the state. So let's add our state type. It's by adding a type up here. So our state can either be a splash, playing, or game over. And we'll actually do game over in the enhancing part. So the next thing I want to do is create that private variable active, because this will actually handle what our state needs to be, depending on if this is true or false. And then I'm going to update the start method so that when you start the game, it'll change the active private property. So you'll see I've added when you start, active is going to be true, and we're going to notify the state to change and recompute so that it goes into a different state. And I'm going to do the same for end. So when the game's over, active gets set to false. We notify the state, hey, you need to recompute, and it'll change. So that's it for our view model. We can compile this, and I've kind of set up a little test page to test that. So if I go into here, I get logged out an object. This is our view model, and you can see that we have 0 points and our state is splash. But if I do vm.start, then it starts the game, and then I log out VM again. It's going to show that the active is true, the active property we set, and then the state is now into playing. So we can see our view model is working correctly. Okay, so now we want to actually create the widget. So if I open up my guessware widget file, I have something really simple where I just have a constructor. I have the render method returning hello world, and that's pretty much it. So we're going to call this widget guesswhere, and it's going to extend the widget class. So the first thing I want to do is add some properties to this class. I want to add a view property, and this is going to depend on the view model's view. So you can actually alias properties where if you change one, the other one gets updated, and vice versa. And then I'm also adding the view model here, the view model property, and it's going to re-render whenever the choices change, or the countdown property change, or the view model state changes. So you'll see TypeScript needs a couple things to compile correctly. Let's go up to our decorators and add the alias of. Okay. So now I'm pulling in the alias of decorator from our accessor decorators. And so now that's going to compile correctly. And I need to import our view model that we just set up. So I'll go up to the top here and just import that. Okay. So now it's no longer underlining that, so that's good. Let's just make sure that's working. Okay, it looks like it built correctly. Now we want to modify the render method so it's not just showing this hello world here. We want to see something different. So I'm going to update that. And instead of hello world, I want to add a div with some classes and also render our game start menu. So let's add our classes. We have a bit more than we did in the first widget we created, because this one's a little more advanced. But it's the same thing. I'm just creating an object called CSS, where I define the root classes and all of the classes I'm going to use in the DOM structure I create in the render method. So now that that's there, we can start actually making that render method. And so that's what I'll do. I'm going to copy our render menu protected method. So in our render function, I'm calling this render menu. And then I'm creating a protected method here that is going to return some JSX. And the reason I'm making it protected is so that if someone else extends this widget, they can overwrite this method and define their own custom user interface if they wanted to. And so this render menu is going to create a div node, and this is going to act as our game starting menu. It's going to have the title and a button to start. And then when you click that start button, it's going to call this onStart private method. Let's copy that, put it down in our private methods. And all this is going to do is tell the view model to start the game. So let's compile that and see what we get in our widget. Okay, so now we got our guessware and a button. And if I click start, oh, it doesn't know what that is. And that's because I need to bind this method to the so that it's bound in the constructor so it knows where this is basically. So let me do that. Compile. Did it compile? No. I guess it's got to wait for the map to load. There we go. Okay, so now it's starting the game. And so we have this basic menu. Let's actually get the rounds rendered now. So we want to change our render method so that it's not just displaying a menu, but it's also depending on the state and rendering around. So I'm going to update it. And basically what's changed is I'm now, depending on the state, if it's already playing, it's going to render around instead of just rendering the menu always. So now we need to find what rendering around means to our widget by returning some JSX. So again, I'm going to create another protected method here. And our round is going to consist of our choices, an A or B choice. And we're going to render our heads-up display, which will be like the point total. And then our choice A and our choice B. So you'll see that those methods need to be defined as well. So let's do that. We're going to create one for rendering the heads-up display. And this will be our score, and it'll just show the points that we've got so far, the correct guesses we've got. And then we've got to render our choice. So this will be location A or location B. And it will return a div container that has basically the choice name and a background color. So you'll see that we need to actually import what a choice is so we can use it. So let's import the interface for choice, which was defined in the other widget, or the other class, I'm sorry. So the choice is just like whether it has a name, it's just the name and the feature basically. So the name of the choice and then the graphic associated with it. And then if we go back into our render choice, when that choice is clicked, we need to say, okay, ViewModel, this choice has been selected. So we want to add a private method on choice. Go in Java private methods. So when a user clicks on a choice, it's going to call this event, and it's going to supply that choice that the user made to the ViewModel via the choose method. And then lastly, I need to bind this on choice in the constructor. So go bind that. Okay. So let's compile this and test it, make sure it's working. TypeScript compile. Okay. So now, let's wait for the map. Okay, so now if I start this, I'm now into a round. I can guess, okay, this is Palm Springs, or this is San Diego, or I can guess wrong, I can just keep guessing, and you'll see sometimes the points are added and sometimes they're not. So just depending on my choice. So cool, we got the round rendered. Now we want to update it for the game over state. So go back into our render method, and right now we have a state for whether it's playing, we're going to render the round, and if it's game over, right now we're not rendering anything. So what we want to do is render a game over. So let's copy that. And we need to define what the game over looks like, how the DOM is constructed. So I'll copy this, create another protected method, game over. And in the game over, it's going to show a header saying game over. It's going to let the user know their score. And it's going to have a couple of buttons to retry the game or to just quit. And then it'll take them back to the starting menu. So we need to define what those on-click handlers do. We'll put those in our private methods. Okay. So when they retry, we're going to end the current game and start a new one. And if they decide to quit, we're just going to call the end method, and it'll take them back to the splash screen. And so let's bind those in the constructor as well. Okay, I should be able to compile this now. And, but the game over part, the thing we need to do is we're going to make sure we can update that. So if I go into my main TypeScript file, where did that go? Right there. Okay, let's compile. So the thing is, it's never going to end unless we tell it to end, because we haven't set up a timer or anything like that. So, oops, I gotta open this over here. So I have my main file here, and what I've done is I've set a timeout. So after a second, I'm just gonna set the state of the ViewModel to game over, just so we can see how it looks. So let me compile that. So now after a second, it goes into the game over mode, and we can quit, and it'll go back to that. Or we can retry, and it's going to start the game again. Cool. So we set up a really simple widget. Let's recap this real quick. We paired a view and a view model and showed you how those kind of worked with each other. We rendered a property from a view model. We wired up some interactivity with the onClicks. And we learned to apply styles to the DOM nodes. And then we dynamically rendered user interface depending on a property's changing. But we can go further than that. So to go further, I'm going to turn it back over to Franco.
Thanks, Matt. So Matt showed you the value of how we develop widgets by separating the views and view models. The goal is to keep the views as simple as possible and just have them focus on UI, interaction, styling. And everything else, if you push it to the view model, you get the benefit that you can reuse that core game logic. So now we have the foundation for the game that Matt showed you earlier in its full form. So I'm just going to summarize some of the changes that we can do afterwards on the view model and the view to reach the final desired state of our game. So to start off, and by the way, I've commented out the sections that are identical to the previous step. But to start off in the guessware view model, we'll be adding a timer because having a timeout of 1 second to have your game end, it's not fun. So we'll introduce a timer to drive the game over state, how each round, the duration of each round. We'll also introduce a utility to dynamically fetch the game data. And I won't go into the details of this module, but it basically creates a feature layer, queries it for the geometries of all the countries in the world, and then we'll prepare randomized entries for our game. So when we create our view model, it's going to use the utility and create this game engine that we call it. And once it's ready, once it's fetched all that game data and prepped some of the randomized choices, it's going to resolve. And then we're going to assign that internally into our view model, and we're going to notify the state property as modified. And that's because now we want to, since we can't really play until we get the game data, we want to mark the widget as being, we want to disable it until this data is ready. So we'll go to the state property in a few minutes, but this is a way of telling it to refresh the value of this property when the choice engine is set. And then whenever the choices property changes, we're going to make sure to have the view go to that randomized chosen location. We have some variables here that determine the delay between each round, because whenever the user guesses, we want a small delay so we can show the user the right answer before moving on to the next choice. We also introduced other properties that we'll use in the view to keep track of the current game countdown, as well as the total duration of a game. And here's the state property. And now, for example, if we don't have the choice engine, now we're going to have it be in the loading state. The rest should apply similarly. And now, when the countdown reaches, when the countdown elapses, it's going to go into game over. So no more having something external control when your game ends. So now when you call the start method, it's going to randomize choices with the choice engine, and then it's going to set those, reset the points, and start the timer, and mark the state as needing an update. Then when we choose, we are going to return a different object with the correct choice, as well as a method for the view to tell it that I'm done showing to notify the view when it can show the next choice. Similarly, with the end, we're just going to stop the timer and refresh the state property. And the following private methods are just to get the next choices from the choice engine and to start and stop the timer. In terms of the view, we've enhanced the CSS. We've added way more classes to add that interactivity because we want different classes to be applied when a choice is hovered, when a choice is correct, when it's being shown to the user as the correct one. So we add all these classes up front. We have a reference to the current result that's being shown to the user. So once they choose, we'll keep a reference to that result. And in order to know which of the two choices is the correct one, the ViewModel is now going to keep track of the countdown. So whenever the countdown changes, it's going to re-render. For menu, we just added a few more classes. We added an icon to make it look nicer. We are disabling it whenever the ViewModel is loading. Whenever we render a choice, this is where we apply all those different classes to kind of give it that nice polish. We also use a few icon classes to denote when a choice is correct or incorrect. And then, for example, when you submit a choice, this is where we tell the ViewModel what our choice was and whether it was right or wrong, and then we just wait for it to tell us when we can move and show the next set of choices. For the heads-up display, all we're doing in new versus the previous step is displaying a countdown timer, and we're doing that with SVG, because with JSX you can inline your SVG, and the cool thing is you can reference properties inside of the JSX. So in this case, for the shape of my timer, I can reference properties that I compute earlier using ViewModel properties. And I also added a utility to get the right color to show the status of the timer. So once I do that, I can get something similar to what Matt showed you earlier. So now we have this timer count using the countdown that's coming from the ViewModel. Whenever we select a choice, it's going to apply the correct CSS classes to mark it as correct or incorrect, and show the proper icons, and keep the same thing. It's going to keep track of my points, and then once this game elapses, it's going to go to the game over screen and allow me to either retry or quit entirely. So once you have the base there, you can add a little bit more polish and make it look more like what you originally wanted it to look like. So with that, we're going to recap, and this session we showed you how to set up your environment to start writing a widget with the JavaScript API and TypeScript. We showed you how to write a guesswork class, which ended up being the foundation for our game. We showed you how to create the view and wire it to the ViewModel to produce our guesswork widget, and we also enhanced it to give it that extra polish. There are some additional resources here that you might find interesting, and you'll get a link to the slides and demo code at the end. And before you leave, please take our survey and let us know how we did, what you liked, what you would like to see in other sessions next year. And with that, we can move on to question time.
The slides are right there if you guys want to take a picture, get the bit.ly URL. This is where you can get the presentation as well as the source code and steps to do this yourself if you wanted to. Does anyone have any questions? Yes? Yeah, so the question was, how would you package this widget and deliver it to multiple apps? Yeah, I mean, it just could be like the CSS in a folder with the widget itself and the ViewModel, and then you would have your app set up to pull in that package. So that's how we kind of did it in this example, where we set up a Dojo package, defined our app, and then we know where to require those and import them.
Yeah, from there you can if you have some sort of build utility to kind of compact that and have it be like a single file, for example, you can also do that. So you would just ship the CSS and the JavaScript as another option too.